Right. So this is welding. Okay. So when you want to manufacture, okay, when you want to fabricate, you know what you have designed something, correct? The structure, for example. So then you want to join the structure because if you design the structure, the basic material for the structure, for example, just like this one, hollow types. Okay? So this is the basic materials. These are the basic materials that you could buy in the market. Okay, in the market. So you just could buy, for example, these materials. So it's quite long. Then you need to cut. After you cut that materials, then you need to join the materials. Okay, for example, you need to have these types of design. Okay. So you have first parts, then this is the second parts, part one, part two. So then you have to think how to join part one, the first part and second part. And you have to think as a designer, you have to think either your structure will be disassembled or permanently joined. Okay. If you think that this part one and part two, okay, later the user need to disassemble. So you have to think. So for example, the structure need to be stored. Okay, need to be stored. So from the big size, and then becoming a smaller size. So you just have very limited space to store. So you need to disassemble the structure. So you have to think how to disassemble the joint, for example. Okay, you may use bolts and nuts, and also you have to think maybe using a clip. Okay, so that after assembles it's easy for the user to disassemble it on to store to keep your design safe. Okay, but a certain application, so you don't need. I think many applications you don't need to disassemble. Okay, so so you have another application also because if it is permanent, if it is permanent, so it's like even though from the beginning this is two different parts, but when you do the permanent joints, so it is look like just one part, just one part. Okay, so actually this is in your drawing, in your engineering drawing, it's like sub-assembly because you have two parts. Okay, so in detailed drawing, so you have part one and part two. Right. So if you permanently join this part one and part two, it is like uh, as a one part because it's quite strong. It's very strong. Okay. So this is the one of the method to join a couple of parts, okay, permanently. Okay. So these weldings is the strongest and the most common method of permanently joining steel, okay, component together. So when you design something for different parts, okay, different parts. So you have to think how to join, either using bolts, using clip, or using welding methods. So okay, many welding techniques available. So I think you will maybe you when you are in industry, so you will see so many types of welding. So arc welding is the most important since it is adaptable to various manufacturing environments and is relatively cheap. Arc welding means kalau you tengok uh, in many type in many shop, okay, kalau kedai motor ke kan dia gunakan that weldings, ada rod, ada api, kan arc tu api kan, arc welding. So dia bakar that rod, kan bakar that rod tu, so rod tu akan diletakkan between the parts, okay, between the parts. So dia akan bakar rod tu, so rod tu akan cair, dan dia akan join those parts, two parts, okay, or three parts together. Okay. But when we weld, we have to think, okay, first safe and another one is economy. Okay, first safe and one is economy. So these types could be safe, but not really economic. Okay, this type, it is economic, but it may be not really safe. So we have to think. Okay, so both character, okay, both elements, safety and the economics. Okay, this chapter consider on arc fillet welds types only. Okay, kalau you tengok arc welding ni, so this a rod, kita panggil rod. Okay, dia ada kena ada sumber, okay, from electric, okay, and gas, kan. So this a type of welding. These two joints, these two parts, this one part, and the one is one part. Kemudian dia join. Okay. This also one part one, and two parts. So therefore, when you as a designer, when you generate drawing, so fabricator will see your sub assembly. So this is sub assembly because it has two different parts which is joined using welding methods. Okay, sub assembly, two different parts. Okay, this is not one part. These two different parts, and fabricator or manufacturer will take these parts. Okay, cut this part according to your detailed drawing, and also this base. Okay, cut this base and make a hole. Okay, then this part 1 and part 2 will be joined together permanently using welding methods. Same as this one. Okay, this is the bead, kita panggil dia weld bead. Welding ni kan, this welds ni, okay, kita panggil weld bead, convex weld beads. And this is poor because dia tak ada macam ni lah, poor. Okay, so for the beads, apa yang kita ada, tiga segi like this one, triangles. So the effective area is the smallest areas we could panggil throat area. Okay, so this one, okay, this one H and this one is T. So this is H, this is H, okay, and this is T. Okay. Dan ni kita panggil dia, we call it throat length. Throat length, T. Okay, this could be failed due to shear. Okay, this is the symbols of welding, the welding symbol. So it is standardized. It is standardized by the American Welding Society. Also, we use if in our assembly drawing, for example. Okay, in our assembly drawing, if you have this, for example, you have these parts in your assembly drawing. In your assembly drawing. So the fabricator might want to know how to join between these parts and these parts. So in your drawing, so you could show this. Okay. This is a symbol of drawing. So you either fillet type of welds, beads. So this is the H. Okay, like this. Symbol of drawing. So you need to have, if you generate your assembly drawing, so you should have, so it is like to communicate to the fabricator. So when fabricator see your assembly drawing, so they will recognize these two parts will be joined by welding method, okay, and the H is equal to 5 mm. Okay. So to join the parts, so this is for to weld this side and this side. So also these are symbols. There's also symbol. Different symbols. It might have different types of weldings and different throws. Okay. So this one altogether is the same. It depend. Okay, depend on your design and also depending on the strength of your joint. Okay, then the force, this is the force and stress analysis. So we will have one primary stress, okay, or primary load, and the second one is secondary stress. For the primary, first we have axial stress, and then we will have shear stress. And for the secondary, we have bending stress and then torsion stress. So stress, for the axial stress, we use the symbol single prime, just prime is double prime. For the secondary, double prime, and for the primary, single prime. So for the axial stress, we have force, and shear, we have shear force divided by area. And bending, we need to calculate the moment, and for torsion, we need to calculate the torque. Okay, this is, let's say this is the weld, uh, the bit. Okay, kita ada for example macam ni. And on the wall, then we weld here. So we have this bit. So if this is the force, okay, so the force here, so we need to calculate the centroid. The centroid of the weld here. This is the force. So this is the for the primary. We need to calculate for the primary stress. Okay. And if there is a torsion from here, so we need to calculate the secondary. And for bending, then the force, like for example here, so this is for bending. So this is all the secondary. So we need to identify the direction of the forces, and then we need to identify the, the primary stresses and also the secondary. So we have, for the primary, we have two, either axials, these are axials.
For sure.
If from here, so we will have the shear stress, or from here, if the force here, okay, we have axials, if the force this one, this direction, so we have shear force, okay, shear stress. Right. So once we identify the primary stress, then we need to identify the secondary stress. Why we need to identify the primary and the secondary? Why? Because we want to identify, okay, so the point, like if the weld is this one, we need to identify the point here, which area, which point will have more stresses. So from the largest stresses for at each at at any point, okay. So based on that stresses, we will calculate, okay, how the size of the bits, the h. Okay, then we get the t, then we will get the h. Okay, so the size of h. So that when the forces acting on that part, so that part will not fail. Okay, based on the forces acting. So we need to calculate first, identify the primary stresses and also the secondary stress. Okay, for the free body diagram of the welding, so if we have this type of beam, okay, this type of beam, then we weld at the top and then at the bottom. And from here, front view, we will see this the weld. This the weld. And then the forces, the force acting at the top, the end of the beam. Okay. So for the free body diagram of the welding free body diagram. So this is free body diagram for the beam. Okay. So this is a free body diagram for the weld. Okay. Satu kita tengok pada beam, satu lagi kita tengok pada welding. Okay, kita ada free body diagram for the welding. So we just sketch or draw free body diagram for the welding. Okay. So kalau kita lihat, if we see the free body diagram for the welding, so kita just lukis this welds ni lah. Okay. Then we need to find the centroid of the welding area. Okay, of the welding area, the centroid. Kita bergantung pada dua ni, kita cari centroid dia. Okay. Kemudian kita pindahkan forces. Okay, kita pindahkan forces tersebut, all the force to the centroid. To the centroid. So if we have this force, like this one, so what we don't have axial. Kalau kita ada, if we have this direction, we have axial force. Okay, but we don't have this direction. So we just have the force acting at the end of the beam from the vertical, okay, vertical direction. So we just have shear. Okay, we have shear force, which acting at the welding area. So for the welding area, we are focusing at the centroid. Okay, so kita direct shear stress. So kita ada shear. Okay, shear is from the force lah, kan? Kemudian kita cari area. Okay, area. Apa lagi kita ada? Kemudian kita ada, we have moment for the bending. Kita ada torsion, kita ada not torsion, we don't have torsion, but we have here moment. Okay, moment. So we need to calculate the moment and moment initial. Okay, so for the second moment of area, this one, for second moment of area IU, so you need to times the T, this is T. Kan, so you akan dapat this one. Inilah kita akan kira untuk our bending shear stress. Okay, this is another example. If we have this is the weld. This is the weld bit. Okay, this is weld. Okay. It's the weld bit. Kalau kita tengok dekat sini, we have two. Okay, one is the primary. This is the primary. This is the secondary. Okay. For the primary, we have direct shear stress, and for the secondary, we have bending shear stress. So this is, we have single prime, and this we have double prime. At the same location, So we locate the location of the shear stress at the end of the weld bit. Kat sini ujung lah. Ujung ni. Lepas tu kita lukis balik. Okay. Kita lukis balik. Okay. Pertama kita ada the first hujung, the second hujung. Okay. This is direct. Kita nampak, this is single prime, this is double prime. The second ujung, the second end, this is the single prime, this is the double prime. Okay. This is direct shear, this is bending. S for direct shear, this B for bending. Okay. Since it has two kan, kita dua, it has two. Okay. So yang ketiga ni end of third location, right? Okay. So we identify the direction as well. Okay, the direction of the shear all in the same direction. Direct shear, the primary, semua sama. Kan? Ke arah bawah. Tapi for the bending, direction dia berbeza. Satu keluar, satu ke dalam. This direction, one here and one is here. Because kalau kita tengok, this one kan, yang atas at the top, force dia terkeluar, and this is for bending, for moment kan, moment. So one satu dia keluar, satu lagi dia ke dalam. Moment. So dia dalam keadaan berpusing lah. Okay. So sebab tu the direction is different. Direction different. So once we have we have drawn all the force direction. So we need to calculate the resultant force. Okay, the resultant shear stress kan between these two. One is direct primary and one is secondary. And then kita kirakan the resultant. So how to calculate the resultant? We use the Pythagoras theorem. This one. Okay, kita kira macam ni.
Saya bagi dulu. Ya, apa.
Okay. Another one, that is the bending. Actually, this is another cases. If we have the same, this is how we, example, if we have, this is the wall, like cantilever, and this is the other cases is like, this is the wall. Kan, wall dia kat tepi. Tadi wall dia dekat belakang. Ini wall dia kat tepi. Okay. Then this the weld. We weld this one. And the same forces. Okay. Apa yang kita ada dekat sini? Okay. The same free body diagram for the welding. Tapi tadi kita ada okay. Now we have this a beam. Now we have torsion. Okay, kita ada one is direct, and the one is we have torsion.
Question pula tapi himat betul lah.
This actually is another method of calculating the resultant of two types of shear stress. Okay, two type of shear stress. Another one, and the method is we could use the cosine rules, triangles rules. Okay. Kan kalau kita belajar in mathematics, kalau two here, we know this one, this A, this B, this the angles. So we could calculate the C. Kan? So samalah macam ni. Kan? Sama macam ni. So this the rules. Kan? Once we draw, this is the single prime, the direct shear stress, and then the one is torsion, and the one is torsion. Okay. Then we put together single prime and double prime, because torsion is we need to have the direction of the torsion. Okay, direction of the torsion. We have calculated the centroid, and then we know the R1, R2, R3 because that is the torsion later on, because you need to calculate the torque. Okay, so this is the R. All right. So you have primary stress and secondary stress in the same point. Then we need to get the resultant forces from first and secondary, primary and secondary. Okay. So this is the resultant force. So we get this, for example, this area, this and number one. And then we have this one. And how to this A, this B, how to calculate the C. How to calculate the C. So we need to use these rules, cosine rule, or triangle rules. Okay, this is the theta. So you have to look back to your mathematics rules. So basically, this is just to combine two types of forces, primary and the secondary. So for this one, for the bending stresses, for the bending stresses, okay, because it is 90 degrees, okay, 90 degrees. Okay, it's quite easy that you just using Pythagoras theorem. Okay, but if it's not 90 degrees, even for the 90 degrees also you could using the cosine rules. Okay, but this quite easy. But for the not 90 degrees, for the torsion, so you have to use the cosine rule, triangle. So basically, you need to combine, okay, two types of stresses in at one point. Okay. Once you get once you get the resultant force at each point. So you just need to compare which point has the highest forces. Okay, highest shear force. Highest shear force. So from that highest shear force, you calculate the H or T. Okay. So for the next one is second moment area. Second moment of area. Okay. So for the second moment of area, this is centroid. You have to calculate, find the centroid, and it's the B. And for here we call the equation and for the polar moment of inertia, this is the equation. But for the welding, we just have been simplified based on the welding types, okay, the welding area, even the centroid also being calculated. So you could just use the formula to get the centroid. This is the normal types of welding. Normal types of welding. So this strut area, okay, this location of centroids, and this is the second moment of area for this type, and also for the polar moment, second moment of area for polar. Okay, this is the moment of area, second moment I use, and this is the polar moment of area. So also you just use this formula based on this type of welding. Okay. You tengoklah mana D dia, mana B dia. So you just use all the formula. Okay, next is the electrode strength. This is the wells based on the American Welding Society. So this electrode numbers, and this is the strength. This is your yield strength. Okay. So later on, you need just to calculate the safety factor or yield factor. So this safety factor using distortion energy methods. Okay. So using the yield strength is a tau max. Okay, tau max, the maximum. Okay, you have 4 points, for example, here this one, you have 4 points. So which location is the highest, the maximum shear stress? So from if the from which the location the shear stress is the highest, so just take the shear stress and then put here, then you get the safety factor. So this from based on the yield strength. Take the yield strength of the roads. Okay. Okay, this is your take-home quizzes. Take-home quiz. So determine the required well size. Maksud dia apa? You kena cari H dia. Well size is H. Welding E20, E60 root. Dia dah bagi dah. Kalau tak, you kena tengok dalam any catalog. That's why. And the safety factor based on yield, maknanya safety factor based on yield rentang haraplah 0.57. So 2.5. Then you kena cari H. You kena cari H. Okay, the procedure dia apa? The procedure dia pertama, free body diagram of the welding. Free body diagram of the welding. Kemudian apa? Then find the centroid. Okay, then number 2, transfer all the forces and moment to the centroid. Transfer all forces
Transfer.
to the centroid.
Asyik. Ni babi lah dia ni. Macam je.
Nombor 3 apa? You kena pecahkan, classify all the forces at centroid. Okay, you pecahkan apa? What is primary?
Secondary.
What is secondary? So, in primary, ada tak direct shear stress ataupun ada tak axial stress? Axial ada tak? Or bending kan? Direct bending, sama ada direct, ada shear stress, ada ataupun ada tak axial stress. That is primary. For secondary, identify bending and torsion. Okay. Okay, selepas tu nombor 4, so determine the most critical. You dah kira kan 4 ataupun 3 kalau sini maybe 3 lah. This one area tu 2, 3. Endpoint. Okay. So here find the most critical.
Kau kan tunjuk example dulu baru buat quiz lah. Gila. Nama pening lah aku macam ni. Yang tiba-tiba buat quiz dulu. Ya, gila.
Ataupun
Tak jujur. Jawapan.
lepas ni you kena combine lah. Combine primary and secondary. Okay. Calculate the resultant, then and find the critical. Nombor 5, barulah you gunakan all macam ni digunakan all safety factor is 2.5 based on yielding. Okay. Yield strength involve direct and shear stress, so you akan gunakan 0.57 lah macam tadi macam equation yang sebelum ni 0.577. Okay, based on safety factor. S strength divided by max. Okay, slide ni saya letak dekat e-learning. So, you boleh buka e-learning. So, free body diagram, kemudian centroid, semua ada formula yang dia bagilah. Kemudian transfer all the forces as centroid. Kemudian classify primary, secondary. Ada tak primary, which if it has primary, what types of primary? Axials ataupun shear, kemudian secondary, bending atau torsion. Okay. Bend torsion. Kemudian combine dapat resultant, get the resultant force, and then identify the critical. Identify the critical. Cuma kalau you tengok area tu, the area, semua sekali area tu kena ada the value of T. So actually you all your calculations kan ada T kat belakang dia. Ada T lah. Function of T. Sebab at the end you akan dapat P value. Okay, you akan dapat nilai T.
Apa?
Okay, you dapat nilai T
Mana tuan-tuan?
bila you do the equation safety factor. Okay, so you get the value of T. So from the T, so kemudian you akan kira H. Okay, you akan weld size tu H tu based on T. The first you have to calculate T sebenarnya.
God.
Okay, sebenarnya you akan tinggalkan T tu. All the equation you ni tak ada T sebab T not given. Okay, T is not given. So kalau you tengok dekat sini, dia ada value of T. Okay, this is a T. T dia. So this is shear. Okay, this is shear. Max, let's say T max. So kalau kita buat 3D, kalau kita buat 3D, okay. Kemudian kita pecahkan Di tengah, let's say tengah. Okay. So this tengah ni is T. Ini kalau dekat dia punya ni dia panggil B lah. This area. B or D lah. B or D. Okay, B or D. Okay. This is T. This is B or D. That's the D. This one H. This one H. This is T. Tengah-tengah T. Bulan darat ni. So this is well B times T. B times T is the area. We are focusing at the middle sebenarnya. Middle tengah tu. So the area dia ialah T, this is the area. Tengah-tengah. Okay, so kalau this one kita potong, potong dua, ni tengah-tengah dia tu. But T tengah-tengah dia. Focus on the shear. Shear dekat sini kan? Sini, so the forces kat sini, shear stress, shear force kat sini. So the forces tu, shear stress tu, the area yang kita fokus kat tengah-tengah ni. So that is the area. The area. So B is given. B ataupun D panjang well area, well size, well tu dia bagilah. Panjang melekat dekat dinding ataupun any wall. So T is not given. T is not given. So you have to calculate the T actually. So all your equation, so will end with the function, the value is the function of T. The value is the function, will be the function of T. Okay. So later on at the end, hujung sekali, apa yang you akan dapat? You akan dapat you will get safety factor 0.577 SY T max kan? So T max, so this T max is equal to function of T, the value T. Okay. Free body diagram, centroid, okay. I think that's not a problem. Centroid. Just directly you get it. Kemudian transfer all the forces to the centroid. Okay, no problem. Just free body diagram. Okay. Kemudian classify all the forces, central, primary and secondary. This one you need to calculate the primary. So for the primary, you identify sama ada shear ataupun axial dekat situ. So for the axial and shear, you need to calculate the area. Okay, the area. So the area you need to combine the area. Okay, and that area is the function of T. It's the function of T. So all T. So your shear will be in T. So all the T. So either you want to carry T in your equation, ataupun T tu you boleh letak dalam pada unit you lah. You buang letak T tu ke tepi dulu. Tapi jangan lupa ambil balik selepas tu nanti. So nanti you punya polar moment of area J pun sebab you kena times JU times T. So dalam T juga. Okay. Kemudian you punya kalau ada torsion ataupun moment, so since polar moment ataupun first moment, second moment of area, so you kena darab dengan T, so all in T. So you punya secondary pun ada dalam T, 1 over T lah maybe, sebenarnya 1 over T. So kemudian nanti you combine kan, you combinekan the direct resultant force. So it could be also in T, all in should be in T.
Oh shit lah.
So this is just the matter of numbers lah sebenarnya, the matter of numbers. Not really difficult, but matter of numbers. Kan, sebab terlalu banyak numbers kan, itu yang kadang-kadang pening sikit lah, itu je. The matter is not straightforward, not really difficult, but how you manage the numbers. Okay, ada soalan? This take home.
Doctor, basically we're just finding the tau max in T, in terms of T, then we are just plugging into the formula and get back the T and finding H. That's the process, right?
Ya, itu sahaja.
Itu
Sebab,
saja kan, okay,
betul. Sebab at the beginning, you don't, the T is not given. Memanglah T tak memanglah betul T tak given. Sebab if you want to calculate the area, so you the area you need to use T actually, and the polar moment ada T, kemudian apa lagi, second moment ada T. So basically you have to find the T. Kalau T dia terus tu yang menyebabkan berapa ketebalan dia punya size weld tu, H tu. That's the T. Okay. Ada soalan lagi? So free body diagram, okay, saya bagilah free body diagram macam ni lah. Buatlah macam mana pun. Okay. So check centroid dia.
What the fuck?
So pindahkan centroid dia. We identify. Kan. Dan you cari point. Point mana. Sebenarnya you boleh cari lah semua point. You boleh cari mana-mana. All 2 points. Kira-kira lah point ni. Okay. Apa lagi yang you ada? So you transfer lah. Transfer dekat point ni. Transfer dekat point.
Harap sensor situ babi.
The point. So this point. Lagi ada. Okay, kalau daripada sini, so you kena pusing lah, pusing. Point one. So this one pun ada. Kemudian torsion. Okay, torsion. So you kena cari dia. Okay, this is the so this is torsion, torsion. Okay, kalau you tengok dia torsion. So torsion nanti you kena kira lah dia punya guna apa cosine rules. The cosine rules. Okay, so saya bagi dia punya so normally in this point kebiasaannya point 3 lah the most critical. Kalau keadaan macam ni normally point 3 is most critical.
Tengok dia pun blank tu. Asal kita orang buat.
Dan H yang you sepatut dapat ialah this is well size. Dapat bila 12.292. Okay, this is torsion. Kalau torsion, dia akan gunakan this lah. Torsion stress. This is bending, torsion.
Ya, torsion lah.
Torsion stress.
Ni yang
So you cari primary pada tempat point 1, point 2, point 3 dalam T. Kemudian you cari kemudian you cari value of R. Secondary kan centroid kan, you akan dapat centroid ni kan. Bagilah point 1, point 2, point 3. So let's say these are 1, these are 2, these are 3. Okay. So you dapat primary. So you akan kira W. Area semua sekali, maknanya area T 2 kan, 2 B plus D. Kemudian tau point 1, point 2, point 3. Okay. So shear kita tahu berapa, mendapatlah value dia. So this T dalam keadaan T lah, T value. So T ni you boleh letak dekat T sini ataupun boleh dibawa kat sini ataupun setengah-setengah orang dia keluarkan tu 1 over T ni. T you letak kat sini keluarkan. Ataupun just carry all the T. So you will have the value over T. One value over T. Kemudian secondary. So you akan dapat R value, R1. So you take centroid kan, based on centroid you dapat R1, you dapat R2 dan R3. Selepas you dapat tu, dan you akan kira pola moment. Gunakan formula yang dia bagi, so you akan dapat. Kemudian untuk welding, you kena darab dengan T. So, also T. Okay. So, di sini you dapat T, kekalkan T sini, ataupun just take the value dan T dekat sini lah. Okay. Kemudian, shear double prime untuk point 1. So formula dia kan TR1 JW. So dia akan kira tu TR2 JW. Sama juga TU point 3 TR3 JW. So all dia dapat value kan, tadi sebab the T kat sini JW, so akan dapat 1 over T megapascal. So all 1 over T variable. Okay. Selepas tu, you need to combine. Kan? Kemudian, point 1 So you kena combine lah. Macam mana nak gunakan, pecahkan dia X, Y rules lah. Sebab dia mungkin ada dua komponen kan, dua komponen. Since you kena cari the angles, so then how to combine. Cuma these are all the sebenarnya matematik lah. Sebenarnya just all the matematik. Macam mana nak combinekan dia. Sebab dia punya apa, resultant tu kan, resultant so you have to use the cosine rules method. Cosine rules methods, bila you ada two values lah, two values. So this one, two values. Tapi dia punya the direction very very important. Direction is very very important. Okay, so you boleh cubalah. Kemudian you akan dapat point 1, kira point 1, point 2, okay, point 1, point 2, point 3. Kemudian then you compare, then point 3 the most critical. The value of point 3 tu saya tengok. All the mathematics sebenarnya. Balik kepada you punya static balik apa semua. Berapa you dapat value point 1, point 2 selepas you combine kan. Selepas you combine resultant force. After combine resultant force. So ada tricky sikit kat sini, so you have to fikir sikit lah how to, tricky sikit. Okay, any questions? That's the method macam tu lah. Cuma how you get the resultant force. How to you calculate the resultant force tu agak a bit tricky. Ada soalan?
So far, okay, Doctor.
Okay, kalau tak ada soalan, so kita move to your major project, our reports. Any problem, any question, your major project reports. Sharing, share.
Tak ada. Semua nak report tiap minggu bangang.
Doctor,
Eh,
I had a question. If my part doesn't involve any belt or gearing system, should I just complete it with static failure, fatigue failure, and bearing? That's enough, right, Doctor? If the part is rotating, just a shaft.
Yes, that's enough. Because you have divided kan, you dah bagi tugas.
Yes, Doctor. I do the rotating station part.
Yes.
That's why I don't have any belt or anything. Just connect to the motor straight away.
Okay, because you have motors kan. So motors, okay, how you choose the motors?
Oh, so I need to do the calculation and specify the motor that I selected.
Betul. You have to, because you have the rotating, you should have motors because in your project, because they use different motors. Ada apa? Dia panggil stepper motor. Kan? Tapi kita we not consider all that stepper motor. We just use as a normal motor, for example. They rotate continuously, not just stop. Kalau kita tengok, they stop each station kan, a couple of seconds. Stop.
Yes,
But in your cases, we don't. In reality, not. But we try abaikan, neglect the stop at all the stations. The motor will continue rotating. So you kena select the motor because you just use 2 motors kan.
Yes,
So
Doctor.
that we'll call it the wheels, the big wheels tu akan pusing juga. So bila dia pusing dia guna single motor.
Okay, Doctor.
So you have to choose the motor, then you have how to reduce the speed of the motor.
Understood, Doctor.
Okay.
Nanti kalau saya specify any motor from the example of markets or other brochure or manufacturers, okay kan Doctor? Just
Yeah.
an example, okay. Which the
Yeah.
specification, okay Doctor. Okay.
Okay.
Understood.
So yes, you have to find any motor from the market, and then identify lah the speed of the motor. So from the speed of the motor that you find from the market, then you use the value in your calculation. Use the value. Speed of-
Okay Doctor. Understood Doctor. Thank you Doctor.
Okay. Okay, ada soalan lagi? Okay, so bila nak boleh hantar ni, take home. Ini saya bagi 5% 5%. Take home for your welding ni, sebenarnya sama, method of welding dengan bolt sama. So, you boleh faham welding, nanti you boleh pengiraan dia, basically sama. You pun resultant force juga, cuma welding, take the size of welding, bolt, kita take size of bolt. Pengiraan dia basically sama. So, bila you boleh hantar?
Lusa kata.
Siap.
Lusa kata.
Any suggestion?
Next week, Doctor.
Bila? Tarik. Saya akan buka e-learning.
25th.
24 ke Doctor?
24th,
25th.
25th.
21.
Ada lagi? Any suggestion?
24, 25th, Doctor, any of the 2 dates.
Okay, saya ambil yang tengah sikit lah. 23 boleh? Khamis.
Boleh ada.
Okay, Doctor.
Okay
Okay Doctor,
23
boleh.
Boleh ada.
Okay, 23. Saya buka dalam e-learning, so you submit dalam e-learning.